2012. He has published more than 60 research papers in the reputed international journals and conferences. He is the director of the IoT and Cloud Computing Lab established in IIIT Bhubaneswar and currently supervising 4 PhD scholars, 2 MTech scholars, and more than 10 BTech students in the research area of Internet of Things, localization, machine learning, AI, big data, blockchain, cybersecurity, cloud, and edge computing. He involved in several research communities, including IEEE, IEEE Computer Society, ACM, ACA, CSI, IEI, ISRD, etc. Dr. Sharma given several invited talks, webinars, and guest lectures on research methodology, IoT, cloud and edge computing, blockchain, and etc. This is a brief introduction of our today's speaker. Now I request Dr. Suraj Sharma sir to continue with the session. Please, sir. Sir, so, so can you hear me? Suraj sir.
Yes, I can hear you.
Yeah, ji sir.
Yeah, thank you. Thank you for your kind introduction.
Our pleasure, sir. So please continue with the session, sir.
Yeah, sure. Okay, so is it visible to all?
Yes, visible,
Yes, sir.
sir.
Okay, so thank you for inviting me in this particular FDP program. So you might have learned different aspects related to IoT till now. And today, in this particular session, we'll see some practical aspect of IoT. So many theoretical session has already been taken, and I'll give you some glimpse related to the practical aspect of IoT. First of all, if you are getting any trouble to get my voice properly, and so you just inform me so that I'll change my network. Okay, if you are getting any problem, otherwise it will be fine. So as we all know till now, like IoT has gradually transforming the way daily tasks are completed. So in today's world, actually we are surrounding with different IoT infrastructure. Okay, we talk about smart cities, we talk about smart home, we talk about a smart water distribution system. So here in India, we are working towards in that particular way, and IoT is playing a very important role to achieve that. Okay, and you all used to wear the smart watch, right? You all have the smartphone. Most of you are using some home assistant like Alexa or Google Home Assistant, right? So Actually, we are actually surrounded with all these IoT devices, and these devices, why we are using it, because they are making, or these IoT infrastructure are making our life much easier. Here in Odisha, we have an application related to the smart city, which is the smart transportation system here. Uh, Under that, there is the public transportation in Odisha, that is called Mobus. This particular Mobus venture is the example of IoT. Now, what happened in that particular smart transportation system? We have different smart bus stops, and all these buses are connected with the GPS and having the internet connection. And this Mobus is having an application also. So you can download the application in your mobile phone. Now, whenever you want to board a bus for a particular destination, you just have to go into the application and you can find out which particular number of bus will go to your destination, and what is the expected time of arrival for a particular bus stop. You can find even your nearest bus stop when you are on board in the bus, so you can find out what is the expected time of arrival of your destination. So here all these buses, what they are connected with the internet, and they will send their location information constantly to the cloud, and cloud will find out, based on your speed, they will find out the expected time of arrival for a particular destination. And when it is reaching to one stop to another stop, this bus stop is also connected with the internet, and they can interact with the buses, that which bus is there in that particular bus stop right now. So it is a very good example of the IoT application. Here I am just sharing the practical aspect of IoT. Another application of IoT in Odisha, they have just implemented in the city of Puri, and it is based. It is on the smart water distribution system. Right now in Puri city. It is a fully 24/7 water supply is there. What they have done is, from the starting of this water supply, that is from water tank, whatever water we preserve, when it will be flown out of that particular water tank, the water quality has been checked, and based on the water quality, the chlorine has been poured into the water. Then there is there are whatever junction we have with the water pipes, there are different junctions, and in each junction they have now put it the pressure sensor, which will find out the pressure of the water in that particular junction, and based on that they will find out the leakage. So if there is any leakage in any of the junction in the city, they can able to find out, because all these junctions are these sensors are sending the pressure data periodically to the server of that particular distribution system, and they can easily find out in which particular location the leak is occurred. So right now in Puri, 24/7, the water supply is there. Water meter is there. Based on the usage, they have to pay their money for that. And it is a very good system, and a very robust system they have made. And slowly they are moving towards making the same system in Cuttack and Bhubaneswar area. So what I am telling you is, this IoT is gradually is gradually coming into our daily life, and it is making our life convenient. And to use these technology, we can make anything is smarter. Okay, anything is smart. So we all know that what is IoT and what do we mean by IoT? So IoT is nothing but the ecosystem of connected physical objects that are accessible through the internet. So here we are thinking like each and every object are connected to the internet. So generally it doesn't happen, but it feel like each and every object data are getting into the internet, but it is getting through different modules that we'll see later on. The thing in the IoT could be a person with the heart rate monitoring or an automobile with the built-in sensors. So this thing could be a living person or a non-living person. In these things or these objects are attached with the sensors. Sensors are generating the data related to that particular object, and these data will be collected in a gateway node, and from the gateway node it will reach to the cloud for the further processing. The object has assigned an IP address and have the ability to collect and transfer data over the network without manual assistant or intervention. So this is nothing but the definition for the IoT. If we'll talk about the different components of IoT, this component we have also seen in the last class. Like we have this, the first module or the first component of the IoT is this things where the sensors are attached to it. And these sensors are generating the data, and this generated data will be given to the gateway node. Actually, gateway node is connected with the internet, because we cannot connect each and every object to the internet, because we have to give the IP address to each and every object. But if the objects are more, then definitely there will be an issue with the internet connectivity. So the gateway node is actually connected with the internet, and this gateway node will send the data to the cloud, and in the cloud the storage and processing will be done through the analytical algorithm, and the result will be given to the users through different user interfaces. Now, when we have all these components together, we say it is an IoT infrastructure. Okay. Okay. So here, these are different applications of IoT. It is not concise to these applications, or it is not restricted in these applications. There are many other applications. So these are some of the popular applications related to IoT, like smart home. We can make our home smarter. We can put different sensors which can sense the existence of a human being, and accordingly it will on the switch of the AC. It will make a temperature to a AC in a proper way. It will on the light, off the light, right? So all those things can be done. Then there is an example called wearable, where these like your smart watch, right? A different type of smart devices that we can wear, and it will tell if we'll talk about the smart watch, we have the concept of like how many steps we walk, what is the heart rate, what are the blood pressure level right now, what is the oxygen saturation level right now of our body. So all these data, it will be generated, and it will be very much useful when we thought of using it for our medical purposes. Then we have the concept of a smart city. Under the smart city, we have a smart transportation system, smart traffic management system. Then we have a smart, as we have just discussed, water distribution system, smart electricity distribution system, right? Smart hospitals, right? So these are smart garbage management system. So all these are different applications related to the smart city application, which we can have. Then we have the concept of smart grids. It's just like to combine different energy sources together and distribute it, and find out the load of a particular area so that we can distribute the proper amount of electricity there. And there is a concept of a smart meter. So we have the electricity meter in our home, right? But the smart meter will also tells that what are the consumption rate you have at daytime, what are the consumption, at nighttime what are the consumption. These data will be sent to the grid, and based on that they can find it out, like how much time we have to, or how much electricity we have to send to a particular location, and find out the load of it. Then we have the concept of industrial Internet of Things, means the use of IoT in industry. That will be done in different manufacturing sectors, and as well as in chemical plants and all. We have another technology which is called Industry 4.0, which also used in industry as well as manufacturing or non-manufacturing industry. Then we have the concept of connected car. Here we talk about Internet of Vehicle, IoV technology related to Internet of Things. And with the help of connected car, we can visualize the application of autonomous car, the driverless car. Okay. Then we have the connected health. The health data will be sensed by all those different sensors and send it to a proper like a hospital, or we can send to the diagnosis center, or if there is a constant monitoring of a patient, we can send all those data for the monitoring purposes of the patient. Okay. Then smart retailing, we can use the IoT. Then we have the supply chain management. In that we can use IoT. Farming and all, we can use the IoT. So all these are different applications of IoT. As I told you, it is not limited to these applications. We can have many other applications, and I'm sure that in these 3-4 days you might have learned different other applications related to IoT. So as we are looking forward for the different practical aspect of IoT, so in the IoT, as we have just discussed, the component of IoT here, this particular component is your physical component. Here we have actually the wireless network, and this particular network is nothing but wireless sensor network. So here we have a combination of sensors and the actuators which are connected to the object. Sensors are used to sense the environmental data related to a particular object, and actuator are the moving part of that particular object, means it will provide the motion to that particular object. So if we'll take an example of this, let's take an example of smart agriculture. Now what will happen in smart agriculture is, we'll put different type of sensors into the field, the agriculture field. So the agriculture field is my object, right? And in this object we are putting the sensors. Let's say we are putting the soil moisture sensor, the humidity and temperature sensors. These data we are getting from these from this particular field, and we are sending it to the gateway node. Gateway node is connected with the internet, and it is sending the data to the cloud. In the cloud, the processing will be done, and based on the processing, they will find out whether we have to pour some water into the field or not. That particular data will be given to the farmer through the user interface. This user interface could be the mobile application. It may be the messages, right, by which we can send these information to the farmer, that you can on the pump and all. Okay. Second thing also we can do is, because as you can see, this particular line is not a directional, it is a bidirectional line. So here, whatever results we are getting, if the result is saying that we need to pour some water into the field, so what we do is we give the signal through the gateway node to the actuator to on the pump. So the pump will be on through the actuator, and actuator will give is nothing but the relay node here, and we give the signal to the relay node that it will be on or off. Okay. So here we have two things. One is the sensor, another is the actuator. Sensor is sensing the environment, and actuator gives the motion to that particular object which is connected with. So let's say it is connected with the water pump, so it will on the water pump and off the water pump based on the signal will be given by the result, or it may be given by the farmer itself. Farmer will click in their application that on, then the signal will be will go to the cloud, and from the cloud it will come to the gateway node, and from the gateway node it will go to a particular object where the relay or this actuator is there, right? So it will on that particular object or off that particular object, or it will provide the motion to the particular object. So this is one application, as I discussed, related to the agriculture, smart agriculture, right? And here you can apply different sensors as well as actuator. So these are the list of the sensors that we can use. Like this is the ultrasonic sensor, which will tell the distance of the object related to this particular sensor. Then we have a smoke sensor, it will find out the smoke, then it will generate the data. Then there is a motion sensor, if it will find out the human body motion in its vicinity, in its surrounding, then it will generate the data. Then this is the humidity and temperature sensor. It will find out the humidity and the temperature value of any particular object. In that way, we have different type of sensors. So this is nothing but the soil moisture sensor. In today's experiment, we are going to see different sensors here. So the first sensor that we'll see here is the first sensor will be the ultrasonic sensor, that we'll see that how we can use this ultrasonic sensor and what are the different applications in which we can use it. After that, we'll see the humidity and temperature sensor, and at last we'll see this soil moisture sensor. So this particular sensor and this sensor and this sensor, that we'll see in today's practical aspect of IoT in today's session. Okay. Then there are many other sensors that we can use for our IoT applications. Now this is nothing but the actuator. This particular actuator will give you the horizontal motion, and so here when we give the signal, this will be the hydraulic press is there. It will give the movement in that direction as well as in that direction. Then there are different type of servo motors. These are different type of actuators which will provide you the circular motion of any object. Okay, so these are different type of servo motors. It will provide you the circular motion. It will provide you the horizontal motion of it, horizontal or vertical, it based on where you are fitting this. Then this is the example of relay, that is called relay. This particular relay is for the electronic appliances, to make any electronic appliances on and off. So these are all the actuators. These are working based on the signal what they are giving or what they will be provided. Okay. All these sensors and the actuators that we have seen should be attached with some sort of microcontroller or microprocessor. These are some microcontroller and microprocessor. This is Raspberry Pi. This is Nodemcu. This is Atmega microcontroller, and this is Adreno Uniboard. So these are different microcontroller that will be used, and these pins will be used to connect to those sensors as well as actuator. So those sensors and the actuator alone cannot do anything. we have to connect with these microcontroller and microprocessor. These are all computing devices. So here we have some storage, some memory, some processing capability, as well as some microcontroller has the communication capability also. So as we all know about the Raspberry Pi, it is onboard computer, right? It's a on-chip computer. This is the working as a computer itself. Okay, here we have different USB, Ether port are there. Then we can connect here the monitor. We can connect the keyboard, mouse. We can connect even with the network, right? These are smaller capability of a microcontroller. Definitely, the cost of this Raspberry Pi is more than these microcontrollers. So we have the sensors. Okay, we have different sensors. We have different actuators, and we have different microcontrollers. So let me tell you that the usefulness of IoT infrastructure. So why we use IoT infrastructure? We use the IoT infrastructure for two purposes. First, either we monitor any object, or we want to access any object remotely, both remotely. Remotely means we are not near to these objects and we want to access or to monitor those objects. So for that, we use the IoT. All right. So these are the two purposes of IoT. Definitely, who will monitor? Who want to monitor the object? Human being want to monitor the object. Who want to monitor? Who want to access the object? Definitely, human being want to monitor the access or to access the object. And both could be done remotely. Means if the object is not at all near to you, but you can access it as well as you can monitor it. So the first microcontroller or the board that we'll see here is the Adreno Uniboard. This Adreno Uniboard has a microcontroller which is of Atmega. This is with me also, this particular board. So let's see the structure for this particular board, and then we'll see the practical implementation of this particular board. Okay. We have different component on this particular board. The main component here will be the Atmega 328P microcontroller. This is the microcontroller that will be used here. It is for processing any type of instructions. Then we have the input. Here we provide the input to this particular board, the voltage input to this particular board. Okay. This is another USB type. Here also we can provide the voltage input, as well as we can give the instruction, or we can write the program in this particular board. Then you can see there are many pins are there. These are all analog pins which will be used for analog sensors. And here we have different type of digital sensors that will be used. Then we have some pin like ground pin and some voltage pin. Here this is 3.3 voltage output, and here is 5 voltage output. Some sensors or some actuators are working in 3.3 voltage. Some sensor or some actuators are working in 5 voltage power supply. Then there is a ground pin, because every circuitry to complete, we have to give the voltage as well as ground. So for that it is, we can provide the voltage from this to this particular board, from this to this particular board, as well as this is also for giving the input. This pin, with this pin also we can give the input, give the power supply to this particular board. Okay. Okay, so we'll not go into the detail of this particular board. It will take a lot of time to understand that what are the different other component here. But the main component that we'll use here is the pins, okay, and this this port that is called USB B port, and we'll take the data from the computer into that particular board, and also it will provide the voltage. Okay. So the first sensor that we'll see is the ultrasonic sensor. Now this particular ultrasonic sensor, how it is working is there is a signal that will be flown in one particular part of this particular ultrasonic sensor, and from the object the signal will be reflected back and coming into this particular echo part, and based on that it will find out the distance of the object from this particular ultrasonic sensor. Okay, so let's see this particular experiment first. So what we do is we use this particular Adreno Uniboard, and we use this particular ultrasonic sensor, and we'll try to find out the distance with the object of that particular ultrasonic sensor. So what are the different applications that we can apply with this and this? So what we can do is we can create a vehicle, actually. A vehicle we can create. This is we can create a autonomous vehicle, and in the autonomous vehicle, in the front, we can put this particular sensor, and we can on this particular vehicle. Okay, so this particular vehicle, based on the obstacle, let's say we have a path, in this particular path is moving, and let's say here we have the obstacle. So if it is moving in that particular direction and find out the obstacle in its path, so what this vehicle will do is vehicle will change its path. So we can make a vehicle which can sense the obstacle and change its path and move to a different direction. Okay, so that it is not going to crash, so it will not going to collide. So you can make a collision less vehicle, autonomous vehicle, which can move around the room. That easy application that you can make. This application we can use it with different purposes also. Now let's see this experiment with the board I have. I'll show you the board here. Okay, so this is the board I have. This is nothing but the Adreno Uniboard. Okay, this Adreno Uniboard is there with me, as well as we have this ultrasonic sensor with us. Okay, this is the ultrasonic sensor, as you can all see. Now let's go to the code, and we'll see the code first, and then we'll again come into this microcontroller. So what we do is we have the Adreno IDE. Okay. With this Adreno IDE, I have written the code. If you'll see this particular code, so it is very simple code. Here we have a trigger pin which will trigger the signal, For that, we have initiated the pin number as 9. Then there is a echo pin, which is taking the reflected echo signal from the object, and we are making it for a pin like 10. So 9 and 10 is the pin that we have used here. Then in the Adreno IDE, you have to install this Adreno IDE with you if you want to do any type of experiment like this. Here we have two functions. One is called setup function, another is called loop function. Now the setup function will run once. So this particular function is going to run once. And this particular program, which is written here, we are going to put into the microcontroller, which is Adreno Uniboard. So we want to put this particular program into the Adreno Uniboard. Now here we have first created a serial.begin, means there is a serial input, serial monitor here. This particular serial monitor will provide you the output. So whatever output you want to see here, what your sensor or your microcontroller is giving, we can see from here. This is the serial monitor. When we click here, one monitor will be open, just like to see the output in the console. Here we set the mode of the pin as the first pin we have taken as trigger pin, means the 9 number pin we have taken as an output pin, because we want to give the output to the signal. And then there is a echo pin we have made as an input pin. So it is taking the input signal. So trigger pin is giving the or it is just providing the signal, and when the object is coming from the reflection of the object, the echo pin will receive that particular signal. Okay. So for that, this is the two pin we have created, and mode we have set for these two pins. Now the second thing is the loop function. The loop function is going to run for the infinite time. It means that till your microcontroller will be given the power. So till that, this particular loop function is going to execute. So here we have taken two things. One is the duration, another is distance. Digital write, so we make it the high. High means this pin will be on. So if it is be on, the signal will be emitted. Then there is a delay of microsecond, which is of 1000 microsecond delay will be there. Then there is, again, we do the digital write as low. So what we do is we give the signal, means give the signal to this trigger pin. So trigger pin will emit the signal, and after that, in 1000 second, it will be 1000 millisecond, it will do that, and after that it will be off. Okay. Now in that we'll find out the duration. So we take the pulse in, and we'll take the input from the echo pin. We make echo pin as high to take the input, and then we'll calculate the distance. With the duration, we'll calculate the distance. So for that, this is the standard formula to find out the distance from this particular duration. And then we'll print what is the distance that we are getting, and this distance we are getting from in the centimeter. Okay, so it will tell me the object distance from this particular sensor in centimeter. Now this is the IDE, as you can see. In the IDE there is a tab called tool. So in the tool we have to select the board first. So my board is Adreno Uniboard, so I'll select this Adreno Uno here. As you can see, I'll select this, I'll click it. Now if you can see here, again go to the tool. This board will be selected here, and after that the second thing that we have to look is the port. Now the port is nothing but your computer USB port. if you will connect the microcontroller to the USB port, so definitely it will be on. So what I am doing is I am just connecting with the computer, and once I'll connect with the computer, this will be on. Okay. So you can see all those things here. So as you can see the setup here. So what we have done is, this is my Adreno Uniboard. Here the pin number 9 and pin number 10, as you can see here, the 9 and 10 is here. Here the pin number 9 and 10. So 9 is my green one, and the red one is with the 10. This is the sensor we have. This is the sensor we have. This is the ultrasonic sensor. In the ultrasonic sensor, we have different pins. As you can see here, we have different pins. There are 4 pins. The first pin from here, as you can see, this is nothing but the ground pin. This is the ground pin. Then we have this echo pin. Then we have trigger pin, and at last we have the voltage pin. Now this particular sensor is working in 5 voltage. So we have to provide the 5 voltage from here. So I have connected with the 5 voltage. As you can see here, this is the 5 voltage power supply with the yellow jumper. Okay, and this is nothing but the ground pin. This pin, orange pin, is nothing but the ground pin. So you can see we have 4 wires, and this will be connected with all these 4 pins. I made the connection here. So the connection is done. So as you can see, now what I'll do is I'll run the program. So whatever program I have is, I'll run it. So before that, go to the tools, and we'll go to the port and select the USB, this USB, because we have to send this particular program into this particular board, right? So we'll select the USB here. Now the USB has been selected for that. Now I'll upload it. So this is the button for upload. This is the button for verify or the compile the program. So when I do upload, it will first do the compilation. Here you can see the compilation is going on. And then upload will begin. Now the upload will be done, and in the upload, the value will be the program will be given to the board, and it says that done uploading. Now you can see in the monitor the value of this. So it is giving you the value here, as you can see. It is coming 13 centimeter right now. Okay, wait a minute. So I am getting this particular value at every 0.5 second. So every 0.5 second in a delay, or here we have the 1000. So for every 1.5 second, I am getting the value. Okay, so let's see, we'll find out the value again. Okay, the baud rate we have to change to 96 right now. Okay, right now it is giving the right value here. As you can see, now this is the object. This is my mobile phone. The mobile phone, the distance is 1211 right now, and I am just, as you can see, the value is changing to right now 7, 8, 6, 5. So this is how the value is. Actually, you can check it with the scale also, and this will give you the accurate, almost the accurate result. So as you can see, the mobile phone, if I'm moving the mobile phone, the distance is also moving, or distance is also increasing. And when we are putting near to it, the distance is reducing. Right? So this is how you can deal with the sensor we have. Now we'll do one increment here with this particular board. So what we do is, we'll put some LEDs or some signals. Now here, as you can see, the trigger pin is 9, echo pin is 10, it is okay. But we have taken another pin, which is the LED pin. Now what we do is, with the LED pin, and this LED pin we are making as an output pin, what we do is here is, if the distance is less than 10 centimeter, then this LED will go on. And if the distance is, the distance is less than or equal to 10, the LED will go high or on. If the distance is more than 10, this will be low, right? So what pin we have chosen for LED? It is pin number 7. Okay. So let's see how we can connect the pin number 7 here. With this. So this is my board, right? What I'll do is, I'll take one LED here. This is my LED. I'm putting LED has two parts, as we all know, right? Anode and cathode. So the longer pin is the anode, and then we have the cathode. So in the longer pin, we'll put the okay. Now we need 2 words here. So one wire will connect with pin number 7. So here we have pin number 7. This we have used, and another pin we will put into the ground. So ground will be connected here with the ground pin. So I think the orange pin is the ground pin, so we'll connect with the ground pin. Okay, now the circuitry is completed. Now what we do is, we just put this particular program into the board. We'll just check again, the port is ready. Now we'll upload it. The updation is done, as you can see, this is your board. So in the board, it is how much? 10, right? Right now it is 12, showing 12. Now we are decreasing the value here. Now it is 11, now it is 10. As you can see, LED is on. Will reduce, LED is off, right? So with that, you can give some other functionality to your board, like you can move to a different direction if you are in a different direction, or means anything you can do here. So some processing you can do in the board, but the higher processing which generated by these sensors, you can use the cloud always, cloud or the servers, local server always. Okay. So this is one practical aspect of the automation we can have here. Okay. So this is not the full application of IoT. Okay. The IoT should have those 5 components. So it is not full IoT application, but yes, the start with that we can have. So this is one board. I want to let you know other board, which is called Nodemcu board. So this is another board we have. This particular board is called Nodemcu board. Now this board is somehow advanced than Adreno Uniboard. Why it is advanced than Adreno Uniboard? The reason is very simple. Here we have a component which is the Wi-Fi component, as you can see here. Means if the sensor is connected to this particular board, or any actuator is connected to this particular board, you can always connect it to the Wi-Fi. Okay, you can always connect it to the Wi-Fi. It means that this board could be connected with the internet. So this board will work as a gateway node. Okay, so because we all know that the gateway node is the node which is connected with the with having the IP address and connected with the internet. So this board actually you can have as the internet connectivity, and this sensors are attached with the object could be, so the object is actually connected with the internet. So in that way, the internet of a thing could be possible. Okay. Okay, so for that, this is the mini USB port from where we can give the power to this particular board. So this board is working with very less energy. As you can see, this is also the voltage input we can provide here, around 3.3 voltage it will work. Here we have different pins, which are, some of the pins are general purpose input output pin, GPIO pin. We have different pins. All these GPIO pin, we can use it for the connectivity with the sensors. So we can connect it. Here we have the analog pin, only one analog pin, which will be used for connecting the analog sensor. Here we can use it for the digital sensor. Okay. Here you can see there are different output voltages. Is 3.3 voltage ground, 3.3 voltage ground, here 3.3 voltage ground. So all these we can use it to provide the power to sensors as well as actuators. Okay. This is a microcontroller which is called ESP8266 microcontroller, which is working with Nodemcu, and we have the Wi-Fi module which is working in 802.11 standard that we all know that Wi-Fi is working on. Okay. Now with this experiment, we'll take another set of sensor. One is we'll take the Dht sensor, another will take the soil moisture sensor. Okay. So let me show you. So we are going to use the sensor, which is this. This is nothing but my Dht sensor that we are going to use here. In this Dht sensor, as you can see, the first pin is the voltage pin, second is the data pin, and the last one is the ground pin. Okay, that we'll use and we'll try to connect with the microcontroller. For that, let's see the program. So for this session, I have the sample programs. Okay, so in this particular program, as you can see, yeah, so this is the program. Here we use the driver of this sensor because is a hardware, right? It should have some sort of library for that. So this is the library for that. The type of the sensor is this. Then this particular sensor is connected with the pin, which is called D2 pin. Okay, so as you might have seen this. Here it is written, this is D2, this is D0, D1, D2. Okay, either you can use 4 also instead of D2 because it is the pin number 4 and it is also called D2. So any of these you can use for the program. Either you'll use D2 or you'll use 4. So here in the experiment we have used D2. So D2 has been used here. The baud rate here has been changed to 115200. It is the rate from which we can see in the monitor, serial monitor. Then we have the input pin. We have made it this D2. We have taken as an input pin. And because it is a humidity and temperature sensor, it will provide you the reading of humidity as well as temperature both. Okay. So humidity we have taken in one variable called H, and temperature we have taken in another variable called T. So humidity and temperature we have taken here, and every 1 second means every 1000 millisecond it will generate the data. This microcontroller will generate the data. Okay. Now let me show you this. Microcontroller here. So this is the microcontroller that we'll use. This is Nodemcu, and we have the sensor here. This is your Dht sensor. Okay. Now we'll do the connections here. So here we provide a simple connection to it. And this is your breadboard. Here we are connecting this sensor here. Right. This is my sensor. Now we have this microcontroller. I can have it, right? This is microcontroller. This is my sensor. So here the first one is the VCC pin. Okay, so this voltage, I have to provide the voltage here. So, okay, let's check that. I'll put the sensor here. Okay. So first of all, the voltage, we provide the voltage is here. This is the voltage pin that will provide the voltage here. Then we have the ground pin. Just beside that, we have the ground pin. Or here we can use the ground pin. So any of the ground pin which is available, we can use it. Okay. So this is my ground pin, which will go at very last. And then in between we have the data pin. This is nothing but my data pin. It will go to D2. So this is the third pin which will go to the D2. So this is how the connection will be done very easily. Now, because it is connected with the USB port, I'll put the USB port into the system. So I'll put it into the system. I have already put it in. Now, kept it here. Okay, the VCC is this one. So I'll make it like this. Okay. So now my sensor is ready. It is getting the voltage here. As you can see, it's getting the voltage here. Okay. Now, come to this tool part. Because the board is changed, so we have to select the board, which is Nodemcu board here. So Nodemcu 1.0, this particular board we have to select. After selecting the board, let's select the USB port. The port is selected, USB port. After that, we'll put this into the. So the uploading the compilation is going on. After the compilation, the uploading will be done into this particular board, as you can see. So the upload %30 right now. $90, and then we have 100% connectivity. Now we'll see the serial monitor. We'll change the baud rate. Yeah, so it is giving me the humidity and temperature. As you can see, the humidity and temperature it is showing here, right? Whatever the value it is. NaN is, we are not getting the value here, but sometime what will happen here is again and again, every second, if you are thinking that your sensor will generate the data, so sometime it is not possible. So instead the value it is giving the NaN, okay, but it is the value that you have. As you can see this, you can increase or decrease the temperature also. So this, I have kept my finger there. So as you can see, the temperature is increasing to 29, 28 right now. The humidity has been changed to 80% because I have touched it, right? So I removed it, the humidity is coming down, right? So this is nothing but a simple sensor we have, which is producing the data. Now, this data which I am getting locally, I can put into the cloud also, okay? So that also we'll see that how we can put the data into the cloud. So for that, what we do is we use the ThinkSpeak for that. This is a cloud provided by the network company where you're getting the. Okay, I'll show you that. Okay, so ThinkSpeak is a company. Sorry, it is a cloud. It is when you open the ThinkSpeak will look like this. This is provided by the MathWork Incorporation. So here you might have used the MATLAB, right? So MATLAB is the simulator tool you might have used. The same company who's creating the MATLAB, the same company has created the ThinkSpeak. So ThinkSpeak is a cloud and generally used for IoT purposes. Okay. Here you can open your account. So I have already my account. Now what I'll do is I'll go to my channel and I'll create a new channel here. New channel, I'll write the name of the new channel. Let's say this is AICTE FTP and I am working on Dht sensor. So what I want is I want the Dht data. In the first field, I want the humidity value. And in the second field, I want the temperature value. Okay. That's all. These two fields are done. I'll save the channel. Once I'll save the channel, the two channel will be created. One channel is providing me the humidity value. Another channel is providing me the temperature value, which is actually real time. Okay. Now to connect to my program, I have to go to the API key. This API key, there is a two key. One is the read key and write key. Write key is writing the or taking the data from the microcontroller to this particular cloud, and read key is taking the data from the cloud to the microcontroller. So this particular first one, I'll just copy API key and I'll put into the program. This is the program for that. So this is the API key. I required the channel ID also. The channel ID is written here, as you can see. This is the channel ID. That also I'll take here. And I'll put it here. Now this is a program. In this program, because we know that this Nodemcu will provide you the Wi-Fi connection or the connection with the internet. Okay. So this module that will be used is ESP8266 Wi-Fi. This should be included. The DHT we have to include, the ThinkSpeak.h because we want to connect with ThinkSpeak cloud that we have to use. Then we have the SSID and the password. The SSID and the password is the hotspot for my mobile phone. So for that, I'll just on the hotspot of my mobile phone so that it will be connected. Your node MCU will be connected to my Wi-Fi. Okay, and then there is a setup. In the setup, we just change the mode of that particular pin, which is again the D2 pin. We are taking the same pin here, D2 pin, and here the Wi-Fi mode should be created, and then there is a ThinkSpeak we have to begin, and then there is a loop. In the loop, we just connect with the Wi-Fi. After connecting with the Wi-Fi, it will print connected, and then it will read the humidity and temperature value. If the humidity and temperature value is in between 0 to 100, it will just print the value of this humidity and temperature, and the same value it will put into the think speak field. So the first field it will put the humidity value, and in the second field it will put the temperature value. Okay, so these two value will go, and every 1 second the value will be updated into the think speak cloud. Okay, so now what we do is we upload this particular program, and let's see that how the data will be go into the cloud. So I'll just click here to upload. Now first of all it will do the compilation. After the compilation, it will upload the data into the so it is taking some time here. Let's go and see this ThinkSpeak. So ThinkSpeak, we have two view. One is the private view, another is the public view. So in the private view, you can only see the data which is given by these sensor nodes. So you can see the data here in the humidity and the temperature. It will come in the form of graphs. Okay. And here it will come the data, the data will come here. Then there is a public view. In the public view, you can make this particular view as public also. So you can share this particular, the whole data you can share with the public. Okay, I'll do that. First, let's find it out. Do I'm getting the data here or not? If I'm getting the data here, whatever data it is produced by this particular node, the same data I'm getting here or not. Okay, let's do the experiment here. Here we can do some MATLAB analysis also with these data. We can visualize the data also, whatever we are getting here. So it is 100% right now. Let's see the serial monitor. So it want to connect with the internet. So once it will connect with the internet, it will tell us that it is connected with the internet and say it is connected. It's taking some time to connect with this because it should connect with my my system or my mobile phone. Okay, it is taking a lot of time. Let me find out another Wi-Fi here, another. This is another authentication of my my lab here. So in my lab, we have the access point. Let's see whether it is whether it will able to connect with my access point or not. So what will be done is, sorry for that. So what will be done is, once your Nodemcu will be connected with the internet, it will be able to send the data here. And once the data will come here at real time, we can visualize the data from anywhere, or we can, in the same way, we can use this particular window to monitor our object. Okay. Okay. Okay, still it is, it's not connecting. Okay, let's forget it. I'll show you with my previous channel what happened. So okay, let's say this is the channel that I have used previous to today only, just before the FDP has started. So as you can see, the humidity value it is showing today at 1512, and then 1512 after some minutes, and here the temperature value it is showing. So in that way, you will get the humidity and temperature value here in this particular channel. Okay. And from here, from this particular way, you can also import the data. So whatever data you are getting here with the sensor nodes, you can actually download. So it will be downloaded in CSV format, comma separated value format. In that way, you can find it out, this particular data that you are getting in the channel. And further, you can use it for your analysis purpose. Okay. So as you can see, you are getting some data at that particular time. So these are all data that you are getting, as you can see. That you can use it for your experiment purpose. So in that particular channel, all those data has been collected. As you can see, in today 1412 at 9:40 a.m. these data you are getting, and at 3 sorry, yeah, at 9:42 you are getting all those data. So all this data you are getting today. Some data is the, okay, so this is the old data that is on 5/11/2009, but these data are the are the latest data that we are getting here. Okay. Till now it should be connected. I don't know what happened here, why it is taking a lot of time to connect. Let's forget it, as the purpose of this particular showing you these all those experiment is to tell you that how it is working and how we are getting the data into the cloud. We have some more experiments that I supposed to tell you, like how we can create the application, how we can control the any object. Like here in this particular experiment, I supposed to tell you once we'll get the IP address of the microcontroller, then how we can control the LEDs. We can on and off the LEDs through the voice command. Also, we can do that. We can create the applications with this MIT2 App Inventor. It is very easy to use. Easy to use a portal is there in which you can create your own application. Okay. Okay, let's forget it. It is taking a lot of time. Meanwhile, if you have any doubt, you can ask me. It's already the time. So if you have any doubt, you can ask me.
Thank you, sir. Thank you, sir, for the wonderful session and a knowledgeable session. I hope many of us has learned many things about the practical aspects and different boards and sensors. Thank you for the wonderful session, sir.